Hey guys, and welcome to this video in which I would like to discuss one of the relationships that we modeled with an equation and a table of values and a graph. And I want to go a little deeper into something called the slope of a line. And we did depict this relationship using a line. So I want to define what slope means and how we can interpret it both with regard to real-world situations now and when we start to graph linear equations later that don't necessarily describe some sort of real-world relationship. So the relationship we're describing for this specific example, and these concepts are going to work for all sorts of different examples, was that on February 10th, our car had 30,000 miles on it, and since then we put on 3,000 miles every month. So over the course of every month, we drive 3,000 miles. So we defined our variables. Our independent variable x would be the number of months since or after February 10th. Our dependent variable y is going to be the number of miles on our car, and we're going to define this to be in thousands. So of course, 0 months after February 10th, or on February 10th, there were 30,000 miles on our car. And then every time we drove an extra month, our mileage on the car went up by 3,000 miles. And if we were to describe this with an equation, we would use the equation y equals 30 plus 3x. Now I hope that we're intimately aware of the relationship between this equation and this table of values. For instance, this 30 right here represents exactly how much the car, quote unquote, started with, right on February 10th, right when x equals 0. So this 30 is intimately related to this ordered pair 0, 30 in our table. And this 3 is something that we're going to investigate a little bit more right now. This 3 tells us exactly how quickly y changes. In this case, how quickly y grows. Y, or the number of miles in our car, grows by 3,000 miles every 1 month. I could just as easily have written that 3 as a fraction and called it 3 over 1, meaning every 1 month that goes by, our number of miles in the car goes up by 3, in this case, 3,000. And so hopefully we can see exactly how this relates to our table of values, but let's also see how this shows up on our graph. And the first thing I want to talk about is this 30 right here in our equation and this 0, 30 ordered pair in our table of values. That shows up right here on our graph. We're going to talk about this a little bit more later, but that's the point right when x, or the number of months since February 10th, is 0. So right on this axis right here, we start at 30. Now, this 3 represents a rate of change. It's telling us how quickly y changes, how quickly the miles on the car are, in this case, increasing. And so I notice that if we look at this graph, every 1 unit we move to the right, every 1 month, of course, the number of miles on the car goes up by 3,000. So every time 1 month goes by, and I'll even go ahead and draw that. Every time 1 month that goes by, we increase the number of miles on our car by 3,000. Every 1 month that goes by, we increase the number of miles on our car by 3,000. Every 1 month that goes by, the number of miles on our car increases by 3,000. And of course, since the miles are changing at a constant rate, that's why we get a line. Right? Every month we're changing by exactly 3,000 miles. If it wasn't the same amount every month, we might get a jagged line or a curvy thing, but since it's constant at 3,000 miles a month, that's why we get a line. And here's my claim. The steepness of this line, or dare I say the slope of this line, kind of tell us exactly how fast the dependent variable is changing, how many more miles we're putting on every month. And so I kind of want to take a moment to define what the slope of a line means. Okay, so the slope of a line represents what we call the rate of change of y, and whatever variable we're using as our dependent variable, with respect to x, or whatever variable we're using as our independent variable. And that's a bit lofty. Another way to think of the slope of the line is, in this case, the slope is a rate of change of y. So you're asking, how quickly is y changing? And you say, well, what is the change in y? How much has y changed? Has it changed a lot? Has it changed a little? Has it increased? Has it decreased? And for what change in x did that happen? Did that happen over 1 month, 2 months, many months, just a few months? And so this is another way to think about the slope of a line. For this specific line, the slope is 3, or 3 over 1, meaning that for a 1 unit increase in x, for a 1 unit positive change in x, there's a 3 unit positive change in y. Every 1 month that goes by, the number of miles in the car goes up by 3,000. And another way we really like to write change in y or change in x is we use this Greek symbol called delta. Just looks like a triangle, and whenever you see a delta anywhere, and you're going to see it a lot, this just means change in y and change in x. So that's what the slope of a line means. And to kind of highlight that a little more, what if instead of saying that we traveled 3,000 miles every month, what if it was that we traveled 4,000 miles every month? So here's the exact same graph we were using before, but if we were going to travel 4,000 miles every month, you see that the line gets steeper, right? The rate of change has increased and the line gets steeper. If we were to travel 5,000 miles every month, the line would get even steeper. Or if we traveled only 1,000 miles every month, the line gets much less steep. And so you see the steepness, or the slope of this line, tells us how quickly y is changing. Heck, you could even kind of put the car in reverse and drive backwards, and you say, okay, well, every month the odometer has fewer miles on it because we tried to pull a Ferris Bueller and put it in reverse or whatnot. And the last point I want to make, going back to our problem from before, is that this change in y over change in x right here, right, this can refer to, for instance, we often think of a unit rate change. So we also say, how much does y change for a 1 unit increase in x, right, for 1 month? Well, we know that, for instance, in this case, y goes up by 3 every time x goes up by 1, right? And that was kind of shown right here on our x increasing by 1, y increasing by 3. But there's nothing wrong with saying, well, for a 2 unit increase in x, I think that we will see a 6 unit increase in y, right? This is a ratio. For every 1 month, we put on 3,000 miles, but that's the same thing as saying every 2 months, we put on 6,000 miles. Or every 3 months, we put on 9,000 miles, right? It's the exact same thing. For a 3-month increase in time, we should put on 9,000 more miles. And so this is just a ratio right here. We can write a bunch of equivalent ratios, or fractions, if you will. And heck, you can even say that if you were to go back in time and say, well, what happened 1 month ago? Well, if you went back in time, you would have 3,000 fewer miles on the car, right? This is the same thing as saying -3 over -1. So we can kind of use this slope in both directions. And we can also find that slope by looking at our table of values. It's no different, from 2 months later and 36,000 miles and 5 months later and 45,000 miles, right? You want to see from here to here, how fast was y changing? You say, well, what's the change in y? Well, from 36 to 45, let's see, 45 minus 36 is 9. So that was our change in y. And from 2 to 5, well, 5 minus 2 is 3. So that was our change in x. Right, from this point to this point, our slope would be the change in y over the change in x, which is, of course, still 3. And so whatever 2 points you use, or 2 data points, you're always going to find that same slope. So the slope of a line is something we are going to revisit again and again this year, but I wanted to give you an introductory idea of what it is and what it means.